There is an unfolding mystery surrounding the early universe, and current scientific theories are struggling to explain the many oddities that have been discovered. Scientists are encountering a wide array of mysterious objects in deep-field images, the nature of which remains unclear. Recent findings suggest that these objects differ significantly from what we would expect from typical early galaxies. Moreover, the unprecedented views provided by the James Webb Space Telescope, JWST, have stunned astronomers, offering a glimpse beyond the dark ages of the universe. Most scientists agree that the universe began roughly 13.8 billion years ago. However, the strange structures observed in these new images challenge this established timeline, potentially leading to significant revisions in our understanding of cosmology. Given these groundbreaking discoveries, several Nobel laureates have speculated that the early universe might differ drastically from what we previously thought. Some have even proposed the radical idea that the universe might not have a definitive beginning at all. Rather than considering the distant universe as representing the early stages of cosmic history, there's speculation that it might be something entirely different, an undefined phenomenon. The observations made by the JWST have raised fundamental questions. What exactly did it observe at the farthest reaches of our universe? And why are these findings considered potentially revolutionary? Since 1929, we've understood that galaxies are drifting apart because of the expansion of space. This expansion intriguingly lacks a central point, meaning that from any location in the universe, it seems as though all points are receding from you. This gives the illusion that you are at the center of the expansion. What's even more puzzling is that scientists have discovered not only is the universe expanding, but it's doing so at an accelerating rate. Galaxies farther from us are moving away at greater velocities than those that are closer to us. Imagine the Earth at the center and looking out at the cosmos. The farther a galaxy is, the faster it appears to recede. In a region of space known as the Hubble sphere, galaxies seem to be moving away at the speed of light. Beyond this sphere, galaxies are receding faster than light itself. Logically, it might seem impossible to observe light from these galaxies, given that they are moving away faster than light can travel toward us. Yet, contrary to expectations, we can still observe galaxies beyond the Hubble sphere, because the Hubble sphere itself is expanding due to the accelerating expansion of space. This allows even superluminal galaxies to enter our observable range. However, there is a limit to how far we can observe the universe. Scientists refer to this boundary as the observable universe, which extends about 92 billion light-years across. Looking to the edge of this observable universe from Earth, we see the cosmic microwave background radiation, essentially a snapshot of the distant past. The most distant galaxy observed by the JWST, called JWST 14, lies within this observable range. When we look at it, we're seeing it as it was when the universe was just 290 million years old. However, this galaxy has since moved beyond the limits of our observable universe, and we can no longer know what it looks like. Its light can never reach us again, and the galaxy may have since evolved into different stars or galaxies. Beyond our observable universe, there are more galaxies and stars that extend infinitely. It's important to note that the boundary of the observable universe is only relevant to observers on Earth. For other species living beyond Earth, the volume of the observable universe would differ. According to the standard cosmological model, about 14 billion years ago, the entire observable universe and everything beyond it that we can't see was compressed into a tiny, infinite point known as a singularity. But this model only holds if the universe is finite. If the universe is infinite, as it seems to be, then it was always infinite. The Big Bang, in that case, occurred everywhere, not in a specific location. This suggests that the first galaxies did not form in any particular region of space. They formed everywhere, even beyond the observable universe. It seems that matter came into existence throughout the universe at a specific time. The cosmic microwave background radiation we see today is the first light of that matter, coming from every direction. However, recent discoveries made by the JWST challenge these theories. When the telescope peered deep into the universe, it did not just observe early galaxies as expected. Instead, it found strange, bright objects that did not resemble early galaxies. In a recent study published in the Astrophysical Journal, researchers identified 87 galaxies that may have existed just 200 million to 400 million years after the Big Bang. This discovery shocked scientists because our current theories suggest that galaxies couldn't have formed so quickly. Ha-Jin Yen, one of the study's authors, noted that even if only a few of these galaxies are confirmed, it would force us to rethink our understanding of how galaxies formed in the early universe. One particularly fascinating image shows an early galaxy that challenges everything we know about galaxy formation. Normally, galaxies are made up of gas and dust that orbit their center, and these materials are crucial for the formation of stars. After studying many galaxies, scientists have observed that only about 10% of a galaxy's gas turns into stars. But the JWST recently found 3 early galaxies where 100% of the available material had turned into stars. This discovery is astonishing because current cosmological models suggest that it is impossible for a galaxy to turn all of its available matter into stars. These unexpected findings are raising many questions. If these objects are actually galaxies, then the Big Bang model might be fundamentally flawed. It would suggest that the Big Bang could not have produced galaxies like these in such a short period of time. The scientific community is still unsure about what these objects are. Astrophysicist and Nobel laureate Adam Rees, who has long suspected that the scientific community is facing a crisis, says that researchers are presenting more and more unsolved puzzles every day. The big question now is whether we can still grasp the situation, or if science itself is reaching its limits. Since the launch of the James Webb Space Telescope, our understanding of the universe has undergone a dramatic shift. The universe is likely much older than we previously assumed, and galaxies have formed much faster and in a much different manner than our predictions suggested. Moreover, the cosmos may not be expanding from a single point. What happens if dark matter is, in fact, a mistake? And the JWST is already providing new, inexplicable phenomena in the cosmos. Adam Rees is one of the leading experts on the expanding universe. His work on the accelerating expansion of the universe revolutionized our understanding of cosmology, and he was awarded a Nobel Prize in 2011 for this discovery. He, along with his colleagues, made important contributions to our understanding of the expansion of space and the concept of standard candles, supernovae used as tools to measure distances in the universe. But even as groundbreaking as their work has been, new findings are consistently shaking the foundations of our understanding. The isotropic model of the universe, which assumes that the universe looks the same in all directions, is now on the verge of collapse. The idea that the universe is homogeneous and isotropic was once a fundamental part of the cosmological principle. However, recent observations from the JWST suggest that the expansion is much faster than expected, and the assumption that the universe is uniform may need to be revised. To understand this new cosmology, scientists need to focus on dark energy. Although its exact nature is still unknown, dark energy is thought to play a crucial role in the accelerated expansion of the universe. Current theories suggest that dark energy constitutes about 68% of the universe's total energy. Yet, scientists have never actually observed dark energy, making it a controversial and mysterious force. Recent findings by the JWST have further shaken our understanding of dark energy, with new structures and objects appearing older and more developed than previously thought. These observations could indicate that the universe expanded faster or began earlier than we believed. This new data suggests that our understanding of fundamental forces, including dark matter and dark energy, is far from complete. It's likely that we will face a significant revision of the standard cosmological model, but we are not yet ready for that shift. We need more tangible evidence, more images from the JWST, and more discoveries from researchers around the world to piece together a new picture. David Gross, a Nobel Prize-winning physicist, welcomes this crisis, seeing it as an opportunity for new insights. Gross believes that the answers to the greatest mysteries of the universe may lie not in the macrocosm, but in the microcosm. As an expert in string theory, he believes that the fundamental forces and structures of the universe may have counterparts in the subatomic realm. The particles we see today, formed after the Big Bang, may hold the key to understanding the origins of everything. The cosmic microwave background radiation is crucial to this investigation. It provides a snapshot of the universe just after the Big Bang, offering insights into the early universe. However, there is still debate among physicists about how to interpret this data. Some researchers see it as proof of the Big Bang, while others believe it points to the existence of parallel universes. In any case, one thing is clear. The discoveries from the James Webb Space Telescope are forcing us to confront fundamental questions about the nature of the universe. Only time and further research will reveal whether our current models of cosmology and particle physics can be reconciled, or whether we must completely rethink our understanding of the cosmos.